Hello, this is HyderTech. This is the first in what will hopefully be a series of videos which will document and or record my own efforts in satisfying my own curiosity around the production and utilization of hydroxy. The reason for my curiosity is the good work I've observed by the likes of Zero Fossil Fuel, Smart Scarecrow, Stanley Mayer, David Lawton, documentation provided by Mr. Kelly, not to mention the excellent work provided by Bob Boyce and many others. Anyway, to kick things off, I'd like to describe this PWM I've put together. It's based on a design by Zero Fossil Fuel. Its circuit board is based on version 2 of Zero Fossil Fuel's circuit board. I decided to use a larger case because, being all thumbs as I am, I find it easier to manipulate its contents. I decided to use this size of CPU fan and heatsink in order to hopefully provide efficient cooling to more than one MOSFET should I decide to deploy more than one within the case. The 12 volt and ground wires pass through a hole in the case via this rubber grommet. These 4 screws secure the circuit board within the case firmly. The device has 5 connections to and from the outside world. Starting here, we have the PWM positive, which connects to the positive terminal on the PSU. Here we have the PWM negative, which connects to the negative terminal on the PSU. On the other side, we have the PWM cell positive, which connects to the positive terminal on the cell. And finally, we have the PWM cell negative, which connects to the negative terminal on the cell. On this side, I've provided for a socket which accepts a standard 5mm banana plug. This socket is internally connected directly to the MOSFET gate to allow for the straightforward monitoring of the gate pulses on the oscilloscope. Turning the device over, I'd like to describe the internal connections and how they apply to the external components. Starting with the PWM positive, the PWM positive is connected to the PWM negative through a 50 volt, 1000 microfarad, 85 degrees centigrade electrolytic capacitor. The PWM positive is connected directly to the PWM cell positive through a heavy gauge wire situated beneath the capacitor. Finally, for the PWM positive is connected through this red wire here to the switch, which goes on to provide a power supply to the circuit board. Incidentally, the switch has a built-in LED, and this provides a straightforward and quick visual cue as to whether the PWM is powered up or not. The PWM negative is connected via R12, that's this speaker wire here, to the MOSFET source. It's that connection there. This R12, this speaker wire, is a relatively good quality speaker wire with a measured resistance of 0.0015 ohms as per Zero Fossil Fuel's recommendation to allow higher amperage through the device. The PWM negative is connected to the appropriate point on the circuit board to provide it with a ground point, and the PWM negative is finally connected to another appropriate point on the circuit board to provide for the required common ground of the MOSFET source. Now, the MOSFET gate is connected to the circuit board via this red wire here. The MOSFET drain is connected directly to the PWM cell negative via this piece of speaker wire. The MOSFET drain is connected to the MOSFET source through a 1N5408 diode. It may or may not be the most appropriate device for this type of connection, but I could tell you it works just fine for this implementation. The MOSFET source is connected via this blue wire to the appropriate point on the circuit board. This wire carries the volts and amps, which are monitored by one of the comparators employed on the circuit board. Beneath this switch here are the two pins which are used by this plug, and that is where the connections are made for the fan. Notice that here I have a 2 watt 100 ohm resistor as opposed to the 0.5 watt 100 ohm resistor. The reason why I'm using that wattage for that particular resistor is that's the only wattage that was available for that particular resistance. Having said that, after a 12-hour run it was barely warm, and that's how I'm happy for things to feel like on a circuit board after such a long run. Because of that, I'm inclined to maintain that wattage for that particular resistor for this particular implementation. Also, I mentioned earlier that this socket is connected directly to the MOSFET gate. Well, that connection is provided by a pin on this circuit board there. On this circuit board, for test purposes, I've used these single turn potentiometers. These are okay for quick tests like this, but they are not adequate for the precise setting of relevant resistances on potential production devices. Well, that's it for now. Thank you for listening. This is Hydertech signing out.